Logarithm. Logarithm is asking how many of one number do we have to multiply by itself to get another number. So for example, how many 3's do we have to multiply to get to 27? Logarithm. Logarithm is asking how many of one number do we have to multiply by itself to get another number. So for example, how many 3's do we have to multiply to get to 81? So when we look at multiplying, we can go 3 times 3, and that's 9 times 3. We can get our calculators out. 3 times 3 is 9 times 3 is 27 times 3 is 81. So we have to multiply it by 3 4 times by itself to get to 81. So how we would write this in a logarithm to show this would be to say log 3 of 81, and then how many do we have to multiply to get there? Is 4. So for this, let's go over a few things. The 3 is considered our base number. So we've seen this before. It's like saying our exponent. And then 4 is our exponent. So we've seen this before. So if we were to go 3 to the 4th, this would be equal to 81. So it's just a way to rewrite what we've already done and a way to think about it differently. Then 81 is considered our argument. Now let's go over some examples. Example 1, solve for the following. We have the log of 10, so of 100. So what we're asking is, we have our base number, we have our argument, and we're asking how many copies of 10 do we have to multiply to get to 100. So we actually just get our calculators out. We can go ahead and just put in 100, and then we just put in the log of it, and it would equal 2. So we would say 10 times 10 is equal to 100, and we know that to be true. Now, it's important to note that our logs on our calculators are set up to just default it to our base number of 10. Now, let's look at another example. Example 2, solve for the following. We have log of 10, so our base number of 130. So first we're going to put in the number, then press our log button, and we notice we get 2.11. So our log of 10 of 130 is 2.11. Now let's look at another example. Example 3. Solve for the following. We have log of 10 is equal to 12. So we put in 12, we take the log of it, and we see that it's 1.08 as if we round to our nearest hundredth. So 1.08 would be, and so what that means is, if we were to rewrite this, 10 to the 1.08 would equal 12. So this is our exponent, this is our base, and this is our argument. Now let's look at another example. Example 4, solve for the following. We have log of, instead of saying 10 all the time, we'll just go log of 0.0745. So let's go ahead and type that in. And we log it, and we get negative 1.0745. 0.13. So that would be the solution. So notice we have a negative exponent in order to get to 0.0745. Now let's do one final example. Solve for the following. We have log of 10 is equal to 1. So let's get our calculators out. We put in 1 and take the log of it, and we get 0. So log 10 of 1 is equal to 0. And this is because anything raised to the 0 power, like any number, would equal 1. So for instance, if we were to go 2 to the 0 power, that's equal to 1. If we were to go 4 raised to the 0 power, that's also equal to 1. If you were to go to 131 to the 0 power, that's equal to 1. All these are equal to 1. So this is just important to note that anything raised to the 0 power is equal to 1. So for this, our answer is 0, and these were just to signify what this is. But for this problem, we're saying 10 to the 0 power is equal to 1.